The solar system is our cosmic neighborhood, a vast and fascinating system that formed around 4.6 billion years ago from a giant cloud of gas and dust floating in space. Over time, gravity pulled most of this material toward the center, creating the sun, while the remaining matter slowly came together to form planets, moons, asteroids, and countless smaller objects. Everything in the solar system is connected through gravity, and all of it moves in an endless, carefully balanced dance around the sunday. At the center of the solar system lies the sun, a massive sphere of hot, glowing gas made mostly of hydrogen and helium. It is so large that it contains more than 99% of all the mass in the entire solar system. The sun produces energy through nuclear fusion, a process in which hydrogen atoms combine to form helium, releasing enormous amounts of heat and light. This energy travels through space and reaches Earth, warming our planet, driving weather, and making life possible. Without the sun's gravity, the planets would drift away into space, and without its energy, Earth would be a frozen, lifeless world. Moving outward from the sun, the first planets we encounter are small, rocky worlds, known as the inner planets. These planets formed close to the sun, where intense heat prevented lighter gases from settling, leaving behind solid surfaces made of rock and metal. Mercury is the closest planet to the sun and also one of the smallest. Because it has almost no atmosphere, Mercury experiences extreme temperature changes, becoming incredibly hot during the day and freezing cold at night. Its surface is covered with craters, showing that it has remained largely unchanged for billions of years. Venus is the second planet from the sun and is often called Earth's twin because of its similar size. However, conditions on Venus are extremely hostile. Its thick atmosphere is filled with carbon dioxide and clouds of sulfuric acid, which trap heat in a runaway greenhouse effect. As a result, Venus is the hottest planet in the solar system, even hotter than Mercury, despite being farther from the sunday. The surface pressure is crushing, and the planet rotates very slowly and in the opposite direction of most other planets. Earth, the third planet from the sun, is unique as far as we know. It has the right distance from the sun to allow liquid water to exist, a protective atmosphere rich in oxygen and nitrogen, and a magnetic field that shields it from harmful solar radiation. These factors combined have allowed life to develop and evolve over billions of years. Earth's surface is constantly changing due to plate tectonics, erosion, and volcanic activity, making it a dynamic and living planet. Its single moon plays an important role in stabilizing Earth's rotation and influencing ocean tides. Mars, the fourth planet, is often called the red planet because of its reddish appearance, caused by iron oxide on its surface. Mars is smaller and colder than Earth, with a thin atmosphere that cannot retain much heat. Evidence suggests that Mars once had liquid water, including rivers, lakes, and possibly even oceans. Today, scientists study Mars closely because it may hold clues about past life and could one day be explored by humans. Beyond Mars lies a wide region known as the asteroid belt. This area is filled with rocky objects left over from the early formation of the solar system. These asteroids range in size from tiny pebbles to large bodies hundreds of kilometers across. Some asteroids have their own moons, and a few are considered dwarf planets. While movies often show the asteroid belt as a dense, dangerous field, in reality, the objects are spread far apart. Still, asteroids are important because they provide valuable information about the materials that form the planets. Farther from the sun, we reach the outer planets, which are much larger and very different from the inner rocky worlds. These planets formed in colder regions, where lighter gases and ices could accumulate. Jupiter is the first and largest of these giants. It is so massive that its gravity has a major influence on the entire solar system. Jupiter is mostly made of hydrogen and helium and does not have a solid surface like Earth. Its atmosphere is filled with colorful clouds, storms, and the famous Great Red Spot, a giant storm that has been raging for centuries. Jupiter also has dozens of moons, some of which, like Europa and Ganymede, are of great interest because they may contain subsurface oceans. Saturn is known for its stunning ring system, which is made up of countless pieces of ice and rock orbiting the planet. Like Jupiter, Saturn is a gas giant composed mainly of hydrogen and helium. Its rings are incredibly wide but very thin, and they reflect sunlight beautifully. Saturn has many moons as well, including Titan, which has a thick atmosphere and lakes of liquid methane and ethane, making it one of the most Earth-like worlds in some ways. Uranus is the next planet outward and is often described as an ice giant. It contains more water, ammonia, and methane than Jupiter or Saturn. Uranus is unique because it rotates on its side, likely due to a massive collision in its distant past. This unusual tilt causes extreme seasons that last for decades. Its blue-green color comes from methane gas in its atmosphere, which absorbs red light and reflects blue light. Neptune, the farthest planet from the Sun, is another ice giant and is known for its deep blue color and powerful winds. Despite receiving very little sunlight, Neptune has the fastest winds in the solar system, reaching speeds faster than the speed of sound. Like Uranus, Neptune is rich in icy materials and has a dynamic atmosphere with storms and cloud systems. It also has several moons, including Triton, which orbits in the opposite direction of Neptune's rotation. In addition to planets, the solar system contains many moons, each with its own unique features. Some moons are icy, some are rocky, and others have active volcanoes or subsurface oceans. Earth's moon is relatively large compared to its planet and plays a major role in stabilizing Earth's climate. Other moons, such as Jupiter's Io, are extremely volcanic, while Europa may have an ocean beneath its icy crust that could potentially support life. Comets are another important part of the solar system. These icy objects originate from the cold outer regions and are made of frozen gases, dust, and rock. When a comet travels close to the sun, the heat causes its ice to vaporize, creating a glowing coma and a long tail that always points away from the sunday. Comets are like time capsules, preserving material from the early solar system and offering clues about how it formed. Meteors, meteoroids, and meteorites are smaller pieces of rock and metal that travel through space. When these objects enter Earth's atmosphere and burn up, they create bright streaks of light known as shooting stars. If a piece survives the journey and reaches the ground, it is called a meteorite. Studying meteorites helps scientists understand the building blocks of planets. Beyond Neptune lies a distant region called the Kuiper belt, a vast area filled with icy objects, dwarf planets, and remnants from the solar system's formation. Pluto, once considered the ninth planet, is one of the most famous objects in this region. Farther still is the hypothetical Oort cloud, a massive spherical shell surrounding the solar system that may be the source of long-period comets. The solar system is not a static place. Everything within it is constantly moving, evolving, and interacting through gravity. Planets slowly change their orbits, moons experience tidal forces, and asteroids occasionally collide. Over billions of years, these processes have shaped the solar system into the complex and beautiful system we observe today. Despite its vast size and incredible diversity, the solar system is only a tiny part of the universe. Our sun is just one of hundreds of billions of stars in the Milky Way galaxy, and many of those stars have planetary systems of their own. Studying the solar system helps us understand not only our own origins, but also our place in the larger universe. It reminds us that while we are small in scale, we are part of something immense, ancient, and deeply connected.